Ladies and gentlemen, good evening and welcome to Dr. Pluring's lithium iron phosphate battery building part 1 by the fireplace. Here they are, my lithium cells have arrived. 8 160 ampere hours of lithium iron phosphate directly from China. Should be from a, hopefully it should be from a sort of reputable seller of Alibaba. So I'm hoping that they're all right. I've just unboxed them, unpacked them. Boxes are there. They came. The things come out of the boxes completely uninteresting. Just a quick follow-up before we get going on that. On my previous adventures here in lithium charging and experimentations with such. Remember these 3 cells that I got out of the battery pack for the drill? If you don't, never mind. But one of the cells were showing 4 volts before I even started anything. That's this one. And then we had this one that was showing 2.8. Actually, this one that was showing 2.8 before I started doing anything. That seems to be the healthiest one. It'll take a charge and it will discharge, drive a load in a reasonable way. This one though, that was showing 4 volts. These 2 are currently charging here at a constant current of 380 milliamperes. That's apparently 0 volts, but no, it's not the 0 volts. It's just because it has come loose here. One little test rig. There you go. No, come on, mate. Come on, mate. Come on, mate. There you go, 3.9 volts they've gotten up to so far. But this one is getting, well, not hot, but definitely warm to the touch, and the voltage tends to rise rather quickly on it, but it doesn't really accept that much of current or charge. Whilst the other one is completely cool to the touch, has more current flowing into it, and it doesn't get warm from discharging nor charging. So I think the capacity on this one is pretty rubbish, but it's something, and I'm continuing here for learnings and what have you. But that was just a little something I will keep myself occupied with here whilst waiting for these to arrive, and they have now arrived. So I am supposed to start here mucking about with this, and the piece of cardboard that I have underneath here that they are sitting on is more or less representative of the floor space available in the compartment in the caravan where it is originally fitted with the battery and where I intend to fit this. So as we can see, they comfortably can sit like so. First and foremost, as I said, I've just unpacked them, and the packaging was really nice. Seemed very sturdy. Lots of layers of foam and what have you. So that ought to be good. And I can't really see any physical damage to them, even though one of the boxes was slightly damaged. But this seems to have fared well, and I have done one of the checks you can do to see if they have been tampered with, or if you've been had, basically, which is to peel this back and see if this QR code thing is original, or if it's been scratched off and put back on there. But this seems original, so it's looking reasonably good so far. Now, since I've just unpacked them, damn it, what I'm going to do is I'm going to measure the voltages. I'm going to number them and put them in a spreadsheet. So they will be numbered like simply one. You're writing with a black pen on black. It's a bit difficult to make out. Maybe if we put it, yeah, we can put it on the explosion valve, whatever it's supposed to be. Explosion relief valve 6, 7, 8. There, like so. Nice, right? Yeah, sure. And I'm going to put that in a spreadsheet, and I'm going to take the voltage measurement on them here for future follow-up reasons and so on. Here, ladies and gentlemen, you have the results, and they are pretty even, I have to say. They are. One is most of them are here. That the meter fluctuates between 326 and 327, so I put that down as 3265, and one was clearly 327, and one was clearly 326, two was clearly 326, but they're pretty close. I think it seems close to me. This does not tell you a whole lot about the state of charge of them, though, as we are in the envelope where the voltage is pretty damn flat as regards to state of charge. And they're marked like so. So they say that this is a 3.2 volt LiFePo4 cell with a capacity of 160 amp hours, and the voltage was 3.29 when they measured this at the, not the factory, but at an intermediate factory. As far as I understand it, these are made by EVE originally, but then they fail their very strict testing, and they are auctioned off or something, and goes on to various other resellers. But I bought this from what is supposedly the official reseller of the EVE cells that do not pass the very, so claimed at least, very rigorous quality testing for, but that's if they were going to put these in electrical vehicles and such. So then I think this would be fine for powering my caravan. I've had a few thoughts about how to lay this out, and the alternative to doing it like this would be to do it like basically like so. Then it would be slightly less long and a little bit wider instead. But I'm also planning on putting a bit of pressure on this, like so, from there to there, and that gets much more complicated if we have them like this. So therefore, current plan is to have the layout like so. There you go. And then we'll have the see where I put that here. And the BMS will sit about there somehow. So maybe something like that, not directly attached to the batteries, because that will heat them up, but with some sort of spacer in between. And we can have, is this correct? No, this is not correct. We have P minus and B minus. B minus is supposed to come out of the main negative of the battery, which is there. You could turn the whole thing around though if you really want to. Yes, we really want to spend a bit. I think this part of the thing is pretty damn important to get right, to save yourself a lot of headaches and so on further down the line here, I'd imagine. But there you go. Damn it, the fire did not catch on fire in my fireplace. I'm going to have to deal with that later. But there you go. If you have it like that instead, and then you could have, why didn't you simply turn the BMS around, because all the connectors are here, so I would have preferred to have it this way around, I think. But then again, here is where all the MOSFETs are in it. There. So the heat is going to be generated here, and then it's going to rise above whatever components are in there. Does that matter? I don't think so. I really don't think it matters a whole lot, because I don't think that this will get that hot usually, regularly, anyway. So there, something along these lines. So then you'd also flip the entire polarity thing around. Yes, but that's never mind that for now. Cabling wise, I found a bit of stuff lying about here. I have this, for example, which is quite decent for a negative thing, but it is 16 square millimeters, or some other number in American wide gauge, which is actually not printed on the cable. Boo-hoo. But I can run two of these in parallel there, like so, maybe. Put some lugs on them there, and that should be about it. Something like that, right? From main negative to the BMS, and from the BMS to then main negative to actual business end of battery, right? And then of course all the balance cables and such, but we're abstracting that away for the time being. It's a bit heavy, not too bad though. And now when I have this here, I'm sort of regretting not going for either larger cells or more of them. Larger cells will probably have been both the cheapest and the most easy option to go with. Like these are 160 ampere hours, so say you go for 280, or I think there are even 320 cells nowadays. So that would have more or less doubled my capacity, but they would have been twice as large, and it would have been twice as heavy. But I wonder if they would only have been larger height-wise, would still have been completely possible and feasible to get this in here. So that's a top tip: research your dimensions properly before ordering things. But this was quite a significant cost. The cells aren't that bad, $41 each. That's very reasonable, I would have to say. But then shipping was $150, and that's a lot in the scheme of things here, where we are. So, and it also comes with bus bars, like so. I'm not entirely convinced of these here bus bars, because they have put two of them like so. And you see they are not connected, they are just put together like so, with a heat shrink over them. And the way these bend, I'm not entirely convinced that this is copper, that this is plated copper, tin plated copper. This could be brass, because they bend a little bit, or a little bit hard to bend than I would expect copper to be, and the weight is not easy to know. But yeah, the bending properties doesn't feel quite like copper to me. So, but what we'll do here eventually is put these here like so, and so on and so forth, all the way to have them connected in series. I'm not going to do that right now though. It's just brainstorming and doing a bit of initial planning and so on. So I'm thinking enclosure-wise, you're going to have something in the bottom of it. It will probably be plywood, since that is reasonably strong and reasonably lightweight. And for clamping, if you put like this, what you call them, the rods that have thread all the way. I think I actually have a couple of those lying around. So I could have a piece of plywood in the bottom, 2 pieces of plywood on either side here, and then see, there we go, and then a bit of a steel bar there, pushing on the plywood, and then tighten that down with the help of that rod, right? And I'm not going to put like an enormous force on them. I've heard so many things about this, that some people say, I just snug them up and so on, and some people say, just leave it, it doesn't matter, because they will degrade from many other reasons before that ever becomes a problem. But I'm thinking, as you charge these, they will expand and so on. And once they have expanded, they have expanded, and then they lose capacity. So if we can prevent them from expanding and just sort of put something on them to keep them a little bit more snug and tighten up and so on, it won't hurt, I figure. So pen and paper here, because I need to figure out what sort of dimensions I need for my plywood pieces to do this. And my carpentry skills are a complete joke, so I beg your forgiveness even at this early stage about how this is going to look, if it ever gets, done. But yeah, well, it's going to get done. I can promise you that this will become a battery, and it will be possible to use it. I will not probably, in all likelihood, I will not give up until I have a working battery made out of these. But the way to there from here will probably involve quite a bit of swearing and quite a bit of pure frustration and everything you can imagine, and a bit of lost patience and so on. And probably at one point rather say, screw it with this medium. You can, as far as it goes with the plywood and everything, I'm happy as long as it stays together. So if we do try and draw this, there, I'm going to reposition myself here a little bit on the floor there. If you say that this is the base plate, the base plywood plate, like so. Base plate, how large would you like that? Please, so. And how would you like to have it? Yeah, I'd like to have it below the side pieces. So the side pieces here will sit on top of it. Again, my carpentry skills are rubbish, so I'm not going to do any fancy joints or anything like that. Not even going to try. But if we have a base plate which is slightly larger than what we need, and it would be easy to fit all the things on it and so on, I figure. Where did my measuring device go? There, it's right here. So lengthwise, we want that to be the length of the battery pack. Don't short anything out there now. No. Is total of 43.6 centimeters. If this thing can be trusted here. Okay, it has a little bit of wiggle room to it. Right, okay, we do here. I draw out the cells. 1, 2, 3, 4, 5, 6, 7. So from there to there, it is 34.6 or 346 millimeters. You're supposed to always use millimeters here if you're... The professionals always do. The professional carpenters and everything, they always speak in millimeters. 300, and that was wrong. 36. But then this wiggles. This adds at least a millimeter there. So 337. And width of a cell is 170. They're a little bit faced here on the side, so 73. 173. So the base plate would like how much more would you like? Like at least a centimeter on both, on either side, I think, because you put one side plate here of plywood, one on the other, and maybe on the sides as well. But then again, maybe not. Depends. Is it really necessary? You don't want them to be doing this, of course, but to keep weight down and everything, it might be enough to just put a little thing here so that they won't move around like that. And well, maybe you need to compress them that way too. Nah, I think that you need to compress them that way. We're assuming that that's all you need to do. So I'll put a little bit there. So the base plate needs to be I don't know, 173, and you at least 1.5 centimeters more on each side, I'd say. Right, so yeah, and you need to remember to move the camera around to show the good people. No one's watching anyway. Yeah, but this is not. Oops! I already made a grumpy, gripey video about how poorly my YouTube channel is performing. So that's not what we're going to get into now. We're focusing on this. The width here is going to be 173 plus 30, so 193 millimeters in width. I'm not going to go out and cutting plywood now because it's dark and cold, so maybe I'll revise this. And lengthwise 336, and this is actually yeah, for the base plate we should have a bit more because I need to put fuses and maybe a breaker, maybe various things, say. So that's I need to leave myself with a bit of wiggle room. But then thing is, if you look at how the battery cells, the cells are sitting in regards to the space available in the caravan, we have a lot more to play with on the sides than we do lengthwise or depth-wise, or width and depth. Width, depth. You could look at it the other way around, but this is how the compartment is in the caravan. So that's why I have it thinking about it this way. Right. But anyway, the rods with threads. Rods with threads, it's not called that, I don't think, but I know what I mean. Threaded rod. That should be the length of the batteries plus the thickness of the plywood and plus a bit more so you can get a nut on, and also a piece of steel to distribute the force across the whole thing. Right, yeah. So I don't know really threaded rod length, but 336, and how thick is plywood? I'll do it like this: 336 plus you leave to get a nut on, and maybe a washer, and the piece of steel. The steel might be pretty heavy. That's scrap metal that I have lying about that I was thinking of using for this. I think that might be like 4 millimeters. Is it really that thick? I will add a bit of weight, just that, and then you want at least 15, 10, 15, 10 will be the length of rod. And so base plate, I mean, initially I'm going to start by cutting out this base plate and the things that will go onto here, and cut my steel bars to go across, and try and get the threaded rods in a reasonable length. I hope they are at least this long. I think they are. Would prefer, of course, as always, not to go out buying stuff if I can avoid it. And that stuff that I have lying around in my shed since forever, so it's quite satisfying to have that old crap actually get to use, get some use out of it, since I've been keeping it inventory on it for a while. Right, and then these here that's supposed to go here, the little things, supports, or what we call them. And there's supposed to be 2 of those, one for each side, and that is yeah, that doesn't even have to be the length of the entire length of it, because that doesn't really matter if it goes perfectly to the end of the thing here, right? So that can be like 330, say. And the height of them, which we can't really, unless I try and turn this into a 3-dimensional thing, which is, I'm just going to mess it up. Supports, we can draw them out here. There we go. And they are like that. They are 330, and they're it's not super important. It depends a bit of what material I'll use for it. If I might have a piece of lumber that is a reasonable size, and then and if I have that in pieces that I can cut to this length, then that's what I use. So whatever, but it doesn't have to be more than 2 centimeters tall. Around 20. Yep. There you go. And this that goes on to here as well. This, I think that I would like to make the height of it so that I can put something on top here to cover all the terminals and all the connections and everything, because this can't be left open like this. If you were to drop something that is conductive on it, this isn't conductive, but if you were to do that, and this would be a wrench, for example, then really bad things could happen. So we shall try and protect it. So we have the side, what do we call those? What do we call them? Sides. Sides. And those should be slightly wider than the cell. Slightly wider, maybe And the rod, you'd like to have it, don't want it to push on the battery, and don't want it to scave on it and so on. So I would like it to sit out there maybe. And then you'd want a bit of extra on the side as well there for purposes. So say that we make those are, the cell is 173. If we add an inch, 25 millimeters, is that enough? I think I'd rather do like 30. Sort of the width of this thing that will be here. So they will be over the camera again. Yes, doing excellent camera work here. At least the camera hasn't fallen over yet. That's always something. 173 plus support plus a bit, plus 10, say, and then the height of it, that we should be able to work out just now. The height, including the terminal, is 175-ish, or not quite, but close enough. You'd want a little bit of wiggle room maybe. We don't want whatever lid we put on here to be resting on the terminals and possibly putting stress on them. So that's, you said 175 to the terminal, so we make them 180, say. Just thinking a couple of turns here so that I'm not building myself into a stupid corner with this. But there is no way that we're going to build above the height of the terminal now, is it? Not really, because you have that, and then you have a nut. And then you have the balance cable. A balance cable. Now I'm a little bit so-so on this, because just putting the balance cable from the BMS in there, and then having this, still expecting this to bite into this in a good way, while it's not putting more than 4 or 5 Newton meters of torque on it, it's not going to work. It's not going to work very well. At least. So, but since these are actually two, like so, I suppose you could push the balance cable in between here, and then it should not interfere, maybe not interfere a whole lot with the transfer of energy. But the most elegant solution, I saw someone, what was his name? Ray builds cool stuff, I think, a Texan. He has the same approach as me to doing his videos. He says, I'm not editing my videos, I don't have time for that. So I'm actually occupied doing stuff, getting stuff done. Yeah, I couldn't have said it better myself, mate. But he had a really nice idea he had solid bus bars. So he drilled. He's a bit of a perfectionist, apparently, and I'm not quite to his level. I'm not a perfectionist at all. But with straight, solid bus bars, what he did is he drilled and tapped a little hole somewhere in between here, and that's where he attached his balance cable. And that was, I really liked that approach. That's what I was thinking of going with. But then this is not quite that's not how this turned out to be. My bus bars, I suppose I could, if I had doubts as to the material here, I could go and buy a solid piece of copper and make my own, but it's a lot of work, and I'm pretty sure that this will cope just fine. I don't think I will have a problem with this, like not being able to carry enough current. The maximum I expect to draw out of here is 100 amps at the absolute maximum. Absolute maximum 100 amps. They should be rated for I think it is 1C charging and maybe above 1C discharge, so that should be at least 160 amps, and the BMS is rated for 200 amps. But I'm just going to empty my battery out in 10 minutes if I do that, so I don't think so. Still, this is such a rudimentary part of the thing that it's not something that I want to be limiting myself or have a bad connection or anything going on right there. But there you go. I think that sort of wraps up the first part of Dr. Pluring's lithium iron phosphate battery building. I now have some measurements as to what to do with cutting a bit of plywood up, and of course I should sand that down and lacquer it and everything before I even thinking of putting this together. I'm not sure if that's going to happen or not, because I'm a bit what's the word, impatient, or I want to make progress, and at least when it's the first one that I'm doing here. I might build more of this, you never know, since I'm already thinking that I could have fit a lot more in here. I could have fit a lot more, or at least a lot larger of these, or I can have 2 stories of them, and thereby have twice the capacity. But that's, it would be cumbersome. It's easy to just buy twice as large cells. But this was an investment of $600 shipped. This, I believe, about, at least close. So I'm not going to do anything else regards battery cells for the moment. For the moment, we're building this and learning from it. So there you have it. Cutting plywood and everything. We'll see if I'm in the mood tomorrow. It is a bit rough this time of year to go outside at all. It really, your entire body just resists. But I do not want to go outside, mate. Have you seen the state of it? Yes, I have seen the state of it. But I had a sauna now here, and so I'm pretty warm to the core, and that should make me be able to endure the cold outdoors a little bit better. At least that's how we think about it anyway. If there's anything to that or not, I don't know, but it certainly feels that way. So, yeah, but there you have it. I should also mention, if this is the it's a closet basically in the caravan that you open like so, and so if this is the outdoors where the walkway, yeah, fine. On the back wall here, right about here, I don't have the exact height of it, but I should get that, because here there is a piece of convector or radiator, a thing that carries hot water to heat the caravan up. So I need to make sure that I have clearance for that. And I still have lots of space here on this side, so yeah, should be fine. Should be able to do most of what I need to do here, I'm hoping. But I need to keep that in mind, and I need to go out and measure that, so I'm not doing anything stupid. But I still have, might be just about on the limit of the width of that convector, and as far as this goes. But this of course also means that this will sit indoors in the caravan, in the heated part of it. So if you're doing winter camping, we will not be putting any strain on the battery as regards to how cold it gets. It won't get cold, really. It will be nice and cozy in there, I think. And yeah, so that's I think that this is the plan right now anyway. So that's it. That's the end of part 1 of Dr. Pluring's DIY lithium iron phosphate battery. Thank you so very much for watching, ladies and gentlemen, and we'll see how this goes. Cheerio.